Hey kids, Mr. Murray here. Some more trigonometry fun. Today we're talking about the benchmark angles on the unit circle, and we're going to talk about it in degrees and in radians, and hopefully you'll notice some patterns so that these will come to you even faster because you're going to use them so frequently this year and beyond as far as you go in math, calculus next year and beyond. So first we're going to do it in degrees, and I'm going to start with the quadrantal angles because those are nice kind of easy checkpoints here. That here is 0 degrees, of course. Here is 90 degrees. Here is 180 degrees right here on the left side. Straight down is 270 degrees. And then when you get back to the beginning, that's 360 degrees. That's coterminal of 0, right? Puts you in the same location. Now I think I'm going to do those values in radians on the outside. So on the outside, 0 degrees is 0 radians, of course. 90 degrees is pi over 2. 180 is pi, and that to me is probably the most valuable connection to remember because everything's just a fraction of that, right? 90 is half of 180, so that's why it's a half pi, or pi over 2. 270 is just 1.5 pi, so 3 pi over 2. And of course, 360 is 2 pi, right? That's 2 times 180. And in case you are wondering, yes, there's the formula. You can always convert from degrees to radians by, multiplying by pi over 180, right? Or to go from radians to degrees, multiply by 180 over pi. I mean, that is tried and true, and you can always use it. But these you should become so comfortable with and realize that all of these angles we're going to talk about are just fractions of 180. And so they're just nice, easy fractions of pi to work with. And when you see them that way, it feels less like, hey, I'm converting and doing all this work and multiplying and reducing, to like I'm just comfortable with these fractions of 180. So I'm going to start with, in the quadrant 1, the first benchmark angle, the closest one is 30 degrees. And these are all coming from 30, 60, 90s, and 45, 45, 90s, the special rate triangles. So the first one, the smallest one, would be 30 degrees. The second angle is 45 degrees, right? Halfway between 0 and 90. And then that's 60 degrees. So there's your 3 special right triangle angles there. Now in quadrant 2, I'm going to do all of the angles that have a reference angle of 30 degrees. So for example, each one of these is 30 degrees away from the x-axis. So in quadrant 2, that would be 180 minus 30, so that's 150. In quadrant 3, 180 plus 30, 210. And in quadrant 4, 360 minus 30 is 330. So those have a connection. They're all a reference angle of 30 degrees. So they have a big connection when you get into the actual trigonometry, trig values. But let's think about those values in radians. So 30 degrees is pi over 6, right? It's just 1/6 of 180, 3 out of 18, 1/6, so pi over 6. And 150 over here, I'm going to skip around and do all the angles in red, all the 30-degree reference angle ones. 150 is just 5 times 30, so that's 5 pi over 6, or 15 out of 18 if you put it over 180, reduces to 5/6, however you want to think about it. 210, isn't that just 30 times 7, right? 3 times 7 is 210, so pi over 6 times 7, 7 pi over 6. And 330 is just 30 times 11, right? 3 times 11 is 33, so that would be 11 pi over 6. The connection I'd like you to see in radians is that all of these angles that are 30 degrees away from the x-axis, they all have a reference angle of 30 degrees, they're all pi over 6s. They all have that same denominator, pi over 6. Okay, now let's do all the 45-degree reference angles. So that would be all the ones in the middle here. So this would be 135 in quadrant 2, 180 minus 45. 180 plus 45 would be 225. In quadrant 4, 360 minus 45 would be 315. And 45 is, a quarter of 180, or half of 90, so half of a half is pi over 4, a quarter of 180. All of the 45-degree angles are going to be pi over 4s. 135 is 3/4 of pi. 225 is 1 1/4, so 5/4, 5 pi over 4. Right, you're just going to quarter plus the 1 pi, right? 1 plus the extra quarter is 5/4, 1 1/4. And in quadrant 4, 315 is 1 3/4, right? Every one of these there's 1 1/4, 1 1/2, 1 3/4 pi, or 7/4. That's what 1 3/4 is as an improper fraction. So again, notice all the ones that are 45 are all pi over 4s, pi over 4s, pi over 4s. Okay, and now the 60s. 60 degrees and away from the x-axis in quadrant 2 is 120, right? 180 minus 60 is 120. In quadrant 3, 180 plus 60, 240. And in quadrant 4, 360 minus 60 is 300. Now let's look at their radian values. So 60 degrees is 1/3 of 180, so pi over 3. So everything that's 60, you're gonna notice, if you haven't guessed it already, is just going to be a multiple of pi over 3. So 120 is just 2 times 60, right? Or it's 2/3 of 180, however you like to think about it. That's going to be 2 pi over 3, 2/3 of pi. 240 is 1 1/3, right? You're going an extra third past pi, and so 1 1/3 is 4/3. Or think of it as 60 times 4, so pi over 3 times 4, 4 pi over 3. And right here in quadrant 4, 60 times 5 gives you 300, so pi over 3 times 5 gives you 5 pi over 3. So those are all, pretty easy to come up with. And again, all the ones that have the same reference angle have the same denominator when you look at them in radians. But beyond that, there's some other little patterns here. If you notice, they go in this order: 6 4 3, 3 4 6, 6 4 3, 3 4 6. The 6s are always closest to the x-axis. The pi over 4s are in the middle, and the pi over 3s are farthest from the x-axis. And their numerators have a pattern. In quadrant 1, all the numerators are equal to 1. 1 pi over 6, 1 pi over 4, 1 pi over 3. In quadrant 2, all the numerators are 1 less than the denominator. So for example, pi over 3, 2 pi over 3, 3 pi over 4, 5 pi over 6. Because there's going to be times where you have to quickly recognize, you're given an angle, and you'll have to quickly recognize what quadrant it comes from. And that's just a handy little trick to kind of have on tap there. 3 pi over 4, oh, 1 less than the denominator, that's quadrant 2. In quadrant 3, take a look at all these. All of them are 1 bigger than the denominator, right? 7 pi over 6, 5 pi over 4, 4 pi over 3. And in quadrant 4, it's not such a nice pattern. It's not as nice as the other 3, but the numerators are all double the denominator and minus 1. So, pi over 6 that lives in quadrant 4 would be 2 times 6 is 12, minus 1 is 11, 11 pi over 6. 4 times 2 is 8, minus 1 is 7. 3 times 2 is 6, minus 1, 5 pi over 3. So there's all kinds of little patterns here, and I don't expect you to have it all down just because I just gave it to you in one shot. But the more you kind of see and start to absorb, the quicker these things come. So when you really need them, you got all kinds of little funny tricks to to have them at your fingertips. So, okay, kids, that's it for today. And we'll be using these, so hang in there and keep working hard.